Good morning, everyone. I'm excited to present Lashlens, an intelligent system recommending makeup for the eyelashes. As we know, beauty boosts confidence and promotes a sense of individuality, but with the wide variety of makeup products currently, it is difficult to choose the right product according to your need. Therefore, various intelligent makeup recommendation systems have been a recent topic of research, assisting users in finding the right makeup product. But most of the existing systems, they overlook the periocular region, which is an important, it's a significantly important aspect of facial beauty. Most of them focus on skin tone, lip color, facial shape. They emphasize their research on that. In my research, I have found there are particular systems that produce an output with a synthesized mascara. Like they do not focus on the eyelash area, and that's what motivated for the creation of Lashlens. Lashlens is an intelligent system to recommend eyelash care products. The system analyzes eyelashes length and volume to recommend suitable eyelash care products. It analyzes two attributes of the eyelash, which is the length and the volume of the eyelashes. It's also designed to work across various lightings, and it is independent of the skin tone. There are various other features of the system other than a product recommendation, which includes feedback on the eyelashes and application method, and also it provides links for product purchase, etc. And here is an overview of the system flow. Initially, the image is uploaded to the system where it is converted as an edge detected image, and then it will be the length of the eyelash will be calculated, then the volume will be determined, and both the attributes will be passed to the SPM classification, and from that the products will be recommended. I'll be talking more about them in the further slide. And this is the unique aspect of the system where this method was devised to calculate the pixel length of the eyelashes, where initially the image undergoes image pre-processing, and then edge detection is applied to the image where the edges of the image can be identified. And from that, contours in the image are detected using contour detection, and then the contours are filtered as shown in the images. These are the contours. They will be filtered, and then the endpoints of the contours will be identified, and the Dijkstra algorithm will be applied to the between the endpoints to find the shortest distance, and then the length of the shortest path will be identified using the Euclidean distance formula, and that will give you the pixel length of the eyelashes, and it will be applied to various other region of the eyelashes to calculate an average pixel length of the eyelashes. Moving on to the next attribute, the volume. This will be an indication of the volume of the lashes. It's not the exact volume of the lashes. The image will undergo image pre-processing, edge detection as before, and a specific ROI, region of interest, will be selected where edge density calculation will be done. Edge density is the ratio of the edge pixels to the total number of pixels in that particular region. It is again an indication of the volume and not exactly the volume. And The approach used here is a supervised learning approach where a custom dataset was made with 250 images, and each image undergoes the length calculation and volume determination, and that data is fed to the models, and the models are trained using that data. The first one is a CNN regression model, which is a simple lightweight model with 3 convolutional layers and a flattened and a dense layer, and the output is a linear output. And this model is trained to predict the eyelash length. And since this is the very first work in this area, there is no other comparison for this model. And so a ResNet 50 model was trained as for benchmarking. And the next model is a support vector machine, which gets the data, the length and the volume, and it recommends products accordingly. Moving on. The experimental results. We evaluated the eyelash length calculation by comparing our device method to a manual measurement method, and ImageJ software was used for the manual measurement. And the results are summarized in the table below. And the table shows that our methods, eyelash length predictions are reasonably close to manual measurements, demonstrating acceptable accuracy for practical. Moving on. The performance of the CNN and ResNet 50 is compared to see this custom CNN outperforms the ResNet 50. As we can see in the evaluation metrics, mean absolute error is less than that of ResNet 50, and even the same for mean squared error and mean absolute percentage error. A possible reason for this could be the task is narrow and doesn't require a deep architecture. And nextly, the SPM model achieved an accuracy of 75%. And the other metrics are given in the table below. And the precision, recall, and F1 score, though not perfect, it provides a reliable starting point for making eyelash product recommendation based on the features. Like every other system, there are some limitations to this. And the main limitation is the small sample size used to train the model. And also the system for now detects only standard images of eyelashes. And as part of the future work, we'll be expanding the data set to train the models to get a better accuracy. And also there will be transformer-based models, and there will be a real-time feature where users will be able to try on products in a virtual environment and get a better idea of the right products. In conclusion, Lashlens is a novel attempt in bridging the gap in personalized eyelash care recommendation by using techniques, models like CNN, SPM. We enable a hygienic, informed, and personalized beauty decisions. These are the key studies and systems that inspired and guided our project. Thank you for your attention. I'm happy to take any questions.